In short, there's simply not a more convenient plot for two variable statistics than this old scatter plot. That was brought to you by King Arthur, the musical Camelot. Check it out sometime. Okay, we talked about mathematical indices yesterday, so today we're going to talk about scatter plots, which is another way to compare two types of information. So as a light review, this is a picture of a typical scatter plot. Okay, right? The independent variable. The independent variable goes on the x-axis. Okay, so whatever you're controlling. Okay, the dependent variable goes on the y-axis, the results that you're trying to measure. Okay, you've got some kind of setup with some points in the inside where your data is. Okay, and you can see in the top part, or sort of this wedge here, we seem to be trending upward. Okay, it's kind of scattered, but it's trending upward. Okay, and then I have this one little dot near the bottom, or I had one until I just erased that. Okay, so we call that an outlier. Okay, if you have one or two points that differ significantly, we tend not to worry about those. If you have a whole lot, well, then your data is just a big mess, and it's a different situation. Okay, but you've been drawing dots on grids for years now, so I don't think we need to go over that part in too much detail. Start talking about them. Okay. What I do want you to think about right now, okay, is a situation like this. So if I was trying to prove, okay, that the amount of sleep you get helps you get better grades, okay, and I went out and did a couple of studies, and I made two different graphs from two different sets of data, and I got these two here, right, set 1 and set 2. Okay. If I was trying to prove to you that sleep did affect your grades, okay, which graph would I probably want to use? Okay, and maybe talk about that for yourselves for 30 seconds or so, and I'll come back to it. So hopefully you had a little bit of a discussion there, and I hope you would agree that graph number 1, okay, definitely shows a better trend or a stronger trend, right? All those points are really close together and they're moving up, so it definitely looks like how much sleep you have, right? This person has less sleep, okay, and they have worse grades. This person has more sleep and they have better grades. Definitely shows that. Okay. Whereas on the next graph, you know, this person doesn't get a huge amount of sleep and has okay grades, and this person gets way more sleep and gets worse. Okay, that does not show a strong relationship. It's still going up, okay, but it's not strong. Okay, so just like with standard deviation, we can measure how spread out data is from the average. Okay, when we have a scatter plot and some kind of a trend line, a line or a curve, we can measure this. Okay, we can measure how spread out the data is. Okay, so how close does that actually fit to the trend line? Okay, so this concept is called correlation. Okay. So correlation is a measure of strength of the relationship between two variables. Right? So that's all it is. Okay, so the number that we get when we measure it, we call this the correlation coefficient. Okay, and it's given the label R. So correlation coefficient R is an indication of both the strength and the direction of a linear relationship. Okay, it's not slope, okay, but it is strength and direction. The value of R ranges between -1, okay, and I'll show you some examples of that in just a moment, and +1. So for an example of -1, let's add this up here. Okay, -1, okay, means that you have a line of best fit, and all of your dots are on that line of best fit. Okay, and that line is going down. Okay, that is perfect negative correlation. Every single data point is on the same line or curve. Okay, so you can probably imagine then, okay, that perfect positive is just going the opposite direction. All the dots line up in a straight line, okay, and it goes up. Okay, so R equals 1. That's a perfect positive correlation. Okay, again, this doesn't indicate steepness. Okay, if I had, for that example, gone like this, or like this, or like this, okay, it doesn't matter how steep that is. Okay, if all the points are on the line, then it's 1. Okay, 0 indicates no correlation. There's 2 ways that can happen. Okay, 1 is if it doesn't go up or down. Okay, so your points don't move. Okay, that's R equals 0. Okay, and the reason that's 0 is because if we went back to that previous example of sleep, okay, that would be saying that it doesn't matter how many hours of sleep you get. That was my x-axis. It has no effect on grade. Every single person got the exact same grade, no matter what amount of sleep they got. Okay, so there would be no correlation. It has no effect. The other way that you have R equals 0 is that the dots are just extremely scattered. Okay, I can't figure out where I would aim a line of best fit through that thing. Okay, so can't happen. Okay, anything in between. So I'm running out of room here. Okay, but anything in between, right? If my dots are a little spread out, okay, that might be R equals 0.8. Okay, we'll talk about how we measure it in a moment. Okay, right? As the dots get more and more spread out, that number decreases from 1, okay, going down to 0 when they're completely spread out. Okay, so that's what R is showing. Okay, related to that, okay, is what's called the coefficient of determination, which is R squared. Okay, and what this measures is the degree of confidence in predictions from a line or curve of best fit. So for example, if your R squared value was 0.81, you can say that you are 81%, you can say that 81% of your predictions will be accurate, or you're 81% confident. Right? So that's saying that once I have my line of best fit, if I want to use that line to predict the future, okay, or just interpolate some other value, then I can be pretty confident that it's correct, right? That's what that's saying. Okay, so again, when you have perfect correlation, determination is 1, because yeah, all the points were on the line, and I'm sure that if I use my line of best fit, it would turn out the way I expect it to. So for example 1, okay, again, just make a really rough sketch of this in your notes. It doesn't have to be terribly accurate here. I just want you to estimate, okay, what do you think the correlation coefficient might be on these scatter plots? Okay, so again, maybe pause the video here for about a minute or two, discuss, and then we'll resume. Okay, so for part A, okay, it doesn't matter to what you got, okay, as long as you have the idea here, it should be pretty high, right? If I try to draw a line of best fit, okay, the points are really close to it. Okay, not perfect, but they're all really close. So maybe we could call that 0.9 or 0.8. Okay, they're extremely close. Okay, and it's trending upwards from left to right, so it is positive. For graph B, it is trending downward, so it's going to be negative. Okay, but it's more spread out. It's not horribly spread out, but it is more spread out. Okay, so maybe we'll call that 0.6 or 0.5. Okay, it's more spread out, but it is still going down. Okay, for the last one, hopefully you would call this 0. Okay, it's way too spread out to have any meaningful pattern there. Okay. What you definitely don't want to do is start doing connect the dots and trying to make some kind of cool horse figurine or something like that. Okay, like that's not what it's for. Okay, so that's the concept. Okay, how do we measure it? Okay, well, it is possible to do it by hand. Okay, I have seen it, but it is more complicated than standard deviation. Okay, and we haven't been doing that by hand because it's not easy to do. Okay, so you have to do this with technology. So what I need you to work on for the rest of class, okay, and this is important, okay, don't leave it alone. Okay, in the back of the textbook, okay, there's a series of instructions with the graphing calculators. Okay, those calculators most likely are in a red bin in the gray cabinet beside the teacher desk. You can get them out now if they're not out already. You need to go through that and we work with a partner to help each other understand what you're doing. Okay, go through there, go through those steps. It will teach you how to input the data and make scatter plots and read off correlation and find equations. Okay, so I am not going to teach this when I come back. I'm expecting that you have gone through this and learned it on your own. Okay? So once you've gone through those, there are some practice questions that have some data that will allow you to make sure you actually know how to do it. Okay, so take the time to work through it. Okay, and just this last part. Okay, it's not in those instructions. Okay, but this was the steps to do a general reset of the calculator. Okay, second plus 712. And if you want to play the theme from JAWS, press enter. Okay, that's how you reset the calculator. That won't be in the appendices. Okay, but everything else you need to know is in there, and we'll teach you how to set that stuff up. Okay, so work on that, please. And then for tomorrow's lesson, we're going to go over align a best fit by hand as well. Okay, just to review that and show you a better technique. Okay, but for today, get on the graphing calculators and learn how to use those features. Okay. Have a great afternoon, and we'll have another round of this tomorrow.